All right, the first thing we're going to do today is take a little closer look at the definition of a limit. So let's consider some function f of x. And I'm just going to draw a function f of x, all right, just to help you get a little better visual of what's happening here. All right, so here's our x axis, our y axis, and this is our function f of x. All right. So what we are interested in is what happens to the value of the function as x approaches some number c. All right, this is just some arbitrary number c. We could choose it to be 2 or 5 or 84, I don't know, but just some number c. Okay, and we're interested, again, like I said, what happens as we approach c. So we don't really care what happens at c. All right, at c, we don't know. But we want to know what happens as we approach, what happens to the value of the function as we approach c, either from the left or the right. Okay, either from values that are a little bit bigger than c or a little bit less than c. What happens is we get closer and closer to c. So if that if the value of the function approaches some value L as we approach c from either the left or the right, then we say that the limit as x approaches c of f of x is equal to L. Okay, so we're only concerned about what happens as we sneak up on c from either side. We're not going to actually go to c, all right? We're not going to go there. Seems a little strange, I know, but we're not actually going to go to c. We're just going to sneak up on it and see what happens to the value of the function near c, all right, on either side of the x equals c. And if the value of the function seems to be approaching the same number, then we from either side, then we say that the limit is that L value. All right. So let's take a look at these next two examples, and hopefully you get a better sense of what we're doing. So in example 1, we have the function f of x equals x squared, and we have a pretty good sense of what that looks like. It's a parabola with a vertex at 0, 0. Right? And we know what the values are. We could plug in any value we want and get a number, right? So what we want to do is look at what happens to f of x as x approaches 2. We don't actually want to go there. We're going to just approach 2. We're going to get closer and closer. We're going to sneak up on 2 from either side, either values that are less than 2 or values that are a little bit bigger than 2, and we're going to see what happens to the value of the function. All right, so we're going to first of all fill out this table in part A. All right, so I'm just going to put in some values. All right, you can see that 2 is right here in the middle. I don't actually have 2 in the table, but you can see that what we're doing is coming at 2 either from the left or the right. All right. We're taking values that are a little bit less than 2 and getting closer and closer and closer to 2, or we're taking values that are a little bit bigger than 2 and trying to get closer and closer to 2 without actually going there. All right, so let's go ahead and fill out this table. All right, so I've gone ahead and filled out the table so that you don't have to watch me write all these numbers out. So let's look at what's happening here. Right, we can start, let's say we start to the left of 2. Right, so let's start at 1.9. We put in 1.9 to the function x squared, and we get 3.61. And then we put in 1.99, right? We get 3.9601, and then 0.999, and we get 0.3996001. All right, so it's getting closer and closer and closer to 4, right? And we could do the same thing from the other side. So we start, 2.1. That's pretty close to 2, but we can get closer, right? 2.01, right? It's a little bit closer to 2. 2.001, again, a little bit closer to 2. And you can see that the values seem to be approaching 4, which is what you'd expect because the value of the function is 4 when you actually go to 2. But we're not, again, like I said, we're not going to go to 2. We're just looking at what happens as we approach 2. All right, so we want to use this table to estimate the limit as x approaches 2. All right, so we can say that the limit as x approaches 2 of this function, we can either write x squared or we could write f of x because we've named it f of x, is equal to 4. Right, it seems that as we get closer and closer and closer to 2, the function is behaving as we would expect. It's approaching 4. All right. So that seems kind of trivial, right? It seems kind of obvious. Well, the value of the function is 4. Well, wouldn't it go to 4? Um, not necessarily. So let's take a look at this next function, because I think then you'll get a better sense of why limits are important. Because if you look at this next function, we have e to the 3x minus 1 over x. Now, and we want to look at the limit as x approaches 0. All right. Now, if I put 0 in, right, if I try to evaluate f of 0, then I get e to the 0 minus 1 over 1, which is, oh, sorry, not 1, 0, right? I'm trying to look at what happens when x is 0. I get e to the 0 is 1, and then 1 minus 1 is 0. I get 0 over 0, and that's undefined, right? That's undefined. So I don't know what's happening at 0, right? So what I want to do is use limits to see what happens as we approach 0. So undefined. All right, so here's 0. Here's 0 right here. And I've taken some values that are a little bit less than 0, right? So negative 0.1, negative 0.01, negative 0.001, right? And I've taken some values that are a little bit bigger than 0, but approaching 0. Okay, they're getting smaller and smaller as we go, as we come from the right or if we come from the left. So we're going to look at what happens as x approaches 0. We can't go there because it's undefined at 0. But let's see what happens. All right. All right. So let me finish filling this out. 955. Okay. All right. So now I've filled out this table. I've just put in values of x on either side of 0 and calculated values. Just put it into the function and calculate, right? So you can see what happens as x gets smaller and smaller, gets closer and closer to 0. It looks like the function is approaching 3, right? Here I've got 2.995, and on the other side as I approach 0, it looks like it's approaching 3, right? On the other side it's 3.0045. So I would estimate based on my table that the limit as x approaches 0 of f of x is 3 based on my table. Now I could take some smaller values. I could take 0.000001, right, and plug it in and see if that's true, that I am still getting closer and closer to 3. But if you do that, you'll find that you're going to get closer and closer to 3. So that's the interesting thing about limits, is that sometimes you cannot go to the value, right? It's this function is not like the previous function x squared, because we could not go to x to but the previous function we could go to 2, right? We were trying to look at the limit as x approaches 2. We could go straight there if we wanted to. It was defined at 2. This function is not defined at 0, right? So we can sneak up on it from either side. We can take values that are closer and closer and closer to 0 and plug them into the function, and we can get as close to 3 as we want. We just can't go there. All right, we can't, if we try to plug in 0 into the function, it's undefined. All right, so there's a little bit of a sense of how limits work, and I will meet you in the next video.